So our project uses the VL53 LDK time-of-flight sensor mounted on a servo motor and controlled by an ESP32 microcontroller. The sensor measures the accurate distance by emitting laser pulses and calculating reflection time. The servo enables 360-degree scanning, allowing us to map surroundings effectively. Using the ESP32, we process and visualize the data in real time, creating a radar-like system. Next, we are using the ESP32 CAM module to capture real-time images of the rover. The images are processed using the histogram of oriented gradients HOG algorithm, which detects the rover geometric shape and key structural features. By analyzing the gradient patterns, we can accurately determine the orientation and position of the rover in its environment.
So this is a demonstration of the ESP protocol. Here, the sensor, that is the accelerometer gyroscope, is connected to an ESP32, which is now then sending the data back to the receiver using ESP now. The receiver then sends the data using serial monitor to actually visualize the movement of the sender ESP32. So this is the final. This is a demonstration of the movements. This is the movements are completely wireless, and in no way there is a wired connection between the MPU 6050 and the receiver ESP32.
So in this video, we are showing the receiver side of ESP Now rover. This ESP32 sits on the rover and controls all the 4 motors using 8 PWM channels. Each motor has 2 direction pins, front left on pins 26, 25, front right on 24 and 27, back left on 12 and 13, and back right on 32 and 23. All PWM channels run at 500 Hz with 8-bit resolution for smooth speed control. The ESP32 receives command wirelessly through ESP Now. Our controller sends just a single character W, A, S, D or X. This is ESP32 Rover Controller, a simple desktop app built to control rover. At the top, we can easily select COM port and connect to the ESP32. Once connected, the status bar updates instantly. The center panel gives full movement control forward, backward, left and right, and an emergency stop button. Each click sends a command straight to the rover. We can also control everything with keyboard using W, A, S, D or the arrow keys and use the space bar to stop instantly. This is version 2 of our rover controller with live MPU 6050 telemetry. The rover runs using an ESP32 and an MPU 6050 to track motion. We control it with WASD buttons while the ESP32 sends the XY movement data. The UI shows a 2D map with a red position dot and a green trail along with the zoom and clear path options. On the left side of the interface, we have added the serial connection panel and the manual control buttons for WASD movement and stop command. There is also a zoom slider to scale the map and clear trail button to reset the path. With this upgrade, we can now control the rover and also see its motion in real time on the screen.